Well, you're on camera.
What about, do we have left gesture and right gesture?
I don't think the camera goes that way, Nick.
No left and right gesture.
This is why we need live videography. All right, before we start, just a little bit of housekeeping information, I suppose. After lunch today, so we'll just have this lecture this morning. We're just going to talk about the topic for the entirety of the morning session. Then in the afternoon sessions, you'll be back in your regular labs with your lab groups in your lab rooms, which you presumably have not yet been to because we didn't have access to those yesterday. If you do not know where your lab room is, you're skeptical of your ability to find it, there will be lab leaders who meet at the term and dorm conference rooms or lounge rooms that can help you find where you're supposed to be going. And so that should be pretty straightforward, and that will be after the lunch period. Be in your regular labs, you'll have an opportunity to do regular stuff, talk about this lecture, etc. All right. So recently, some scientists in Australia decided they wanted to study the habits of the migration and the prey habits, the territorial habits of the Australian great white shark. The Australian great white shark was thought to be an apex predator meaning it kills everything else and nothing kills it. If you don't know anything about sharks, one, you haven't watched Shark Week, get with it. Two, they are the ultimate killing machine. They have multiple rows of razor sharp teeth. They have jaws that crush like pneumatic crushing claws. They have nerve sensors down the side of their body so they can sense vibrations in the water so they can better detect any animals or creatures near them to more efficiently kill them. Sharks are really good at killing. So these Australian scientists were like, we need to find out more about how these sharks operate. They seem to migrate somewhat randomly. We don't really know what makes them tick. We don't really know if they have family units or anything like that. So they put a tracker in a 9-foot-long, 1-ton great white shark that is a 2,000-pound great white shark. So they put this tracking machine in it to try to find out what the shark was doing. But then on June 6th, just 3 days ago, something happened, and that something was a little weird. The tracker suddenly went 500 meters further below sea level than it had been previously and warmed up to a radically higher temperature. And scientists said to themselves, we've seen this before, but we've only seen it before in the fish that we've tracked that the sharks normally prey on. We've seen it when the sharks eat those fish because the fish will warm up once they get down in a shark's stomach. The shark will drag them to a lower level of the sea in order to feast on them and have a little nap after eating fish. So basically scientists said what had happened to this 9-foot-long, 2-ton shark was that something had eaten it. Something had killed the apex predator. Now this was 3 days ago, and scientists didn't know what killed it. They were like, is it a giant octopus? Is it a giant squid? Is it a kraken? Is it Godzilla? Is it something that we have yet to even hear of? No. Eventually they decided that it was actually just an even bigger shark that ate the first shark. A 16-foot-long, 2-ton great white shark that killed another shark. Now, the fact that scientists didn't really even know why sharks were killing each other, or that sharks did kill each other, or that anything could kill a 9-foot-long, 1-ton shark, sort of indicates to you that we don't really know a whole lot about what's going on in the oceans, and also that the oceans are kind of crazy. A panel of scientists got together and tried to determine the best scientific explanation they could as to why these sharks ate each other. The best explanation they could come up with is sometimes big fish eat littler fish. Section 2, the resolution. The resolution. In policy debate, for those of you who have not done it, and for those of you who have, this should be somewhat familiar. Our debates for the year will center around this resolution, which was chosen by a vote of some old high school debate people and an interstate council that comes down from on high in the mountain and hands us this resolution. The resolution this year is that the United States federal government should substantially increase its non-military exploration and or development of the Earth's oceans. This will be the statement that all of our debates this year, or at least very many of them, will use as their jumping off point. Our research, our work at this camp, and the debates we have will center around this statement for the entirety of the year, and so I think it's pretty important to go point by point and step by step and break down what these words mean and what this resolution really means, because what this resolution means determines what we can say on the affirmative, what we can say we ought to do in order to develop or explore, and also determines what we should be researching as our negative ground, what we should say to respond to those things. So breaking it down word by word just to make sure we understand what's going on with this resolution and kind of what the limits and bounds on what we should be discussing are. The first word, resolved. Every debate resolution begins with this, or at least has tended to for the past recent history of debate. It's kind of a throwback to old school legislative and parliamentary practice where, you know, British people would say, like, be it resolved that Quidditch is good, because that's presumably what the British do. And they just use that before discussing any sort of legislation or anything like that. So they'll say, be it resolved that, that's functionally shorthand, the United States federal government should, blah, 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 blah. It's just kind of a word that's before resolutions. It's not something you should worry about over much. The United States federal government, you probably know what that is. It's that thing that's centered in Washington, D.C. But, you know, some people try to get a little weird with debate and try to interpret words differently. So there might be people who argue that because the F and the G in federal government are little, that means it's the states and not the national government we're talking about. Those people are kind of jokers, and we won't really deal with that at present. But the federal government is referring to the United States federal government, that actor, that set of bodies. It's not referring to the United States of Brazil, which is also a thing that people have tried to do in the past. It is the United States federal government here in the United States. Should generally means ought to or implies obligation or something that we should probably try to do. Substantially increase is the next phrase in this resolution that is pretty important in determining what we can do. Because people say increase means different things. Some people say it means to create a new policy. Some people say it means to augment existing policies. You have to increase something that already exists now. You can't just increase something out of the blue or out of nowhere. And so in order to understand what it means to substantially increase our non-military exploration and or development of the Earth's oceans, we have to have a better understanding of what our level of exploration and development of the Earth's oceans is now. We do a bunch of things involving the oceans. There's a whole bunch of oil and gas exploration and some marine protection and all sorts of regulations that we'll get into a little bit later when we go through more of a glossary of terms. Obama has established an ocean policy. He wanted to do a comprehensive ocean policy that dealt with all things ocean, and this was a bill that passed in 2009, kind of got redone in 2012, and the ideal with this ocean bill for how we relate to the oceans was to streamline environmental regulations and make them a little more enforceable. So basically to clean things up, to allow businesses to work with the ocean, and to still try to protect the ocean environment. Of course, this compromise made both businesses and environmentalists angry because they don't think it's sufficient for their own side of the debate between should we get to drill more oil and, you know, should we protect the environment by not drilling more oil. And so there's a lot of literature and a lot of debate about our current policy and whether or not we should increase it. It's in the resolution. It seems like a silly little word. You might ignore it on your first reading of this, and, you know, Jason, no, yeah, that's right, it's the right, it's grammar, good job. It's is a little word that does a lot of work in this resolution. It's a prepositional, or it's a word that shows ownership. It's a possessive pronoun, and so that means that grammatically, and I hate to talk about grammar at like 9:45 in the morning, but that means that the non-military exploration and or development has to belong to the United States federal government. It is boosting its non-military exploration and or development. The reason why this is important is that it means that the affirmative is probably stuck with defending a government agency doing something, or the government itself proactively doing something, as opposed to saying, hey, businesses should do this, for example. or as opposed to saying, hey, maybe we should let China or a different country do this, because that wouldn't be increasing its non-military exploration, that would be increasing somebody else's. And again, we'll get to that with negative ground. Don't worry about it over much. Non-military. Why do you think non-military is in the resolution? Does anyone want to take a stab at that? Yes.
Because if you added military to that, it would just be such a huge range of possibilities that it would be impossible to really focus in on one plan.
Yeah.
A couple years ago, like a decade ago maybe, they did another ocean topic that did include military exploration, and people were like, yeah, satellite dolphins and stuff like that, so.
I debated that topic. There were war dolphin affirmatives. You put lasers on dolphins' heads and they find sea mines. That's actually a real thing. Yes?
The international maritime, you're not supposed to have military bases in international waters. So I think that could be a factor.
That could be a factor. I think the reason why the framers of the resolution, the people who write this thing, put non-military in there was to try to place some limits on the topic and make it a little bit smaller, because if you include military exploration and development, there's a whole lot of different proposals for what sorts of military things you can do. And I think there's a tendency in debate to sometimes over-focus or overemphasize the military aspects of things, because you'll get better impacts for your arguments if you can say, you know, just like build a naval base somewhere rather than doing some sort of marine environmental protection. You get to bigger, more explosive Michael Bay movie style impacts as opposed to the more like, you know, smaller but still incredibly important, but you know, less exciting and explosive impacts. And so I think they put non-military in there to provide some limits on the topic as to what sort of exploration and development we can do, and also try to focus the debate around the issues of the environment, food sources, and energy, which is what we'll talk about a lot more later when we get into what this topic will really come down to and really be about. Non-military means not belonging to or characteristic of or involving the armed forces, e.g. civilian, which means that if your affirmative is dealing with the military in really any capacity, it's probably not topical under non-military. You can't do things with the military. Exploration. Now, how many people debated the space topic? All right, so we have some people of throwback. You'll recognize this exploration and development thing because it's the exact same phrase that was in the space topic. Exploration of space is sort of intuitive. It makes sense. There's a lot of space out there. We haven't explored most of it, and so we should go explore it. Exploration of the oceans might initially seem to make a little less sense. It's just like, don't we know where they all are already? Didn't Magellan work that out? Aren't we good? But the answer is no, not really. The NOAA, which is the National Oceanic and Atmospheric Administration, that seems right, I have it written down later. They are the branch of the United States federal government that sort of manages ocean stuff and climate stuff. They have an Office of Ocean Exploration, and they say what ocean exploration is exploring the unknown ocean using and developing advanced technologies for discoveries, including new undersea habitats, communities, species, phenomena, and greater understanding of ecosystems. I'll say that again. Exploration explores the unknown ocean using and developing advanced technology for discoveries, including new undersea habitats, communities, species, phenomena, and a greater understanding of ecosystems. So what exploration means in terms of this topic is looking at the parts of the ocean we don't really know a lot about. And really, a lot of the ocean we don't really know a lot about. 90% plus of the ocean we refer to as the abyss or the void because it is dark, it is deep, it is dense, it is difficult to get down there, and it's difficult to really understand what sort of species exist or track them or really understand them. There are a bunch of authors who say that we have a better understanding of the surface of the moon and Mars than we do of the surface at, for example, the bottom of the Marianas Trench, the deepest part of the ocean. And so there's a lot of ocean that we don't really understand. The anecdote that I began with about giant sharks eating other giant sharks demonstrates that there's a lot we really don't know. just about giant sharks. And there are a whole lot of other creatures in the environment that might need discovering. There are a whole lot of other areas that might need discovering. Oceans are deep. They go down for a while. If you go to the deepest point of the ocean in the Marianas Trench, as I mentioned, and you put Mount Everest there, the tallest mountain on Earth, Mount Everest, the very top of it would still be a mile below sea level. A full mile below sea level, which is already past a point where it's very difficult to actually explore. No light penetrates. You can't really see anything. So there's just not a lot of understanding about what's going on in the oceans. And so that's where exploration comes in terms of discovering new things about the oceans. Now, the NOAA, the Ocean and Atmospheric Administration, does make a distinction between exploration and research. They say that exploration is trying to discover new things, new ecosystems, learn more things about the ocean, whereas research is more applied. It's more doing experiments in the ocean with things. I think there are good topicality arguments that research is different than exploration, and so if an affirmative is trying to develop some sort of fancy new technology in the ocean, that is research and not exploration. The and or in the resolution means and or. That's all we're going to say about that. There are again the same genre of jokers who say that the United States federal government is the government of Brazil, might say that and or means both. But that doesn't make sense because it means and or. They would just say and if they wanted it to mean both. It also means or. We've dealt with that. Development. Development is where this resolution kind of gets enormous in terms of the areas and issues we'll be talking about. Now, you might remember this term as well from the space topic if you debated that topic. And it turns out in the context of space development, given that we haven't built a whole lot of stuff in space, there's a whole lot of literature defining what space development is. They'll say, well, it's building colonies. It's like mining asteroids. It's, building space stations and stuff. All sorts of things might be space development. There are far less of those specific definitions when it comes to the oceans. There are far less people who say, this is what it means to develop the oceans. If you Google ocean development, you'll get a bunch of links to real estate. Which isn't terribly useful for the purpose of this topic. Development must be directed toward, and this is one definition, and this is the government's definition, so it might be something worth working with. This is from the Office of Management and Budget. It must be directed toward the production of useful materials, devices, systems, or methods. And they say that development is defined as systematic application of knowledge or understanding directed toward the production of useful materials, devices, systems, or methods, including design, development, and improvement of prototypes and new processes to meet specific requirements. What does that mean? I don't know. I think it means a lot of things. And I think that might be one of the issues we have with this topic and this resolution, is that basically what that definition is just like apply knowledge or understanding toward the production of useful materials. So development is basically like use your brain to do stuff, which means that you can do most anything to an ocean or in an ocean, and it would probably count as development under some definitions. There are people who say development has to be for economic purposes, that if you're developing something, that it has to make money. There are other people who just say, no, it's just changing or improving what exists now. The existing ocean ecosystem, existing sea communication lines, etc. And so development is a really big word that means a lot of different things. It can mean growth and progress. It can mean changing what exists now. It can mean almost anything, which means affirmatives that you debate this year and that you write this year might try to say that any old thing that happens in or on or around an ocean is development of that ocean. There is an argument that this topic is do a thing and put it in the water. Now, there are camps who have already put out affirmatives that are basically like, do a thing and put it in the water. There's been an affirmative put out that was like a college affirmative from a couple of years ago about nuclear reactors, and they're like, you know what, we're going to do those and we're going to put them on the water. Because why not? The resolution, we have all these cards that say they're great, why don't we just put them in the ocean? It simplifies things. And so you'll see a lot of people who try to just pull out the old back files, look at all the old arguments they have, and say, can I do that in the ocean? The answer is, maybe you can. And if you can, then that's probably an affirmative under this topic, assuming it's not a military application or use for the ocean. Of. Non-military exploration and or development of. Of is another word like it's that you'll sort of gloss over and you'll say, that's not very important. Why do we need of? Of might become important given what we said about development meaning potentially anything. You might need the word of as a definition to say that their development is not actually of the oceans. You might have to define of as a preposition in the resolution. The object of development must be the oceans themselves. So the object of this preposition is the Earth's oceans. That means of the Earth's oceans modifies what you have to develop. Now, if you define of in such a way that it is like a term of exclusion, that of is saying it has to be entirely contained within the ocean, which there are definitions of that say that, then maybe some of those development affirmatives that are kind of like related to the ocean or on top of the ocean or near the ocean or just sort of smell like the ocean, those affirmatives might not be topical because they might not be entirely of the ocean. They might be development of some other stuff as well as the Earth's oceans. This will be an argument we have in our packet files that you may have gotten a chance to look at. You may not have. That's no big deal. The affirmative that we put out was an offshore wind affirmative. Now, there's an argument that that offshore wind affirmative isn't topical because the wind's not blowing in the ocean. The wind is blowing above the ocean. So you could say, is that development of the ocean, or is that development of the sky above the ocean? I don't know yet. Those will be top-calorie debates that we have to have. Of Earth, the Earth's oceans, why does it say the Earth's oceans? Yeah.
Because they don't want you to do a topic on any other oceans.
Yeah, what other oceans are there?
Frozen oceans on Mars.
Frozen oceans on Mars? Yeah, they were like, somebody's going to be clever. That same guy who's reading his app about Brazil and saying and/or means both is going to develop Mars's oceans. And we don't want that to happen. So we're going to just make it clear, these are Earth's oceans. This isn't like the red eye of Jupiter. These are Earth's oceans. They are the oceans of Earth. What are Earth's oceans? Does anyone want to take a stab at it? Yes.
Atlantic, Pacific, Arctic, Indian.
Atlantic, Pacific, Arctic, Indian. Bingo. Yes. The Atlantic, Pacific, the Arctic, and the Indian. People try to define oceans in, like a couple of different ways. Some people say they're like the large saltwater bodies. The best definitions that I found are really just, it's those four oceans. The Atlantic, Pacific, the Arctic, and the Indian. Some people say that the Antarctic is its own ocean, but it's not like geographically distinct from the other oceans, so we won't really worry about that. Because there's not any easily defined land surrounding it. So those four oceans are the oceans. This means you can't put things in rivers or seas like the Caspian Sea. It's landlocked, it doesn't count. Those sorts of things wouldn't be topical affirmatives, and there are arguments that things on certain coastal areas might not be as well. Do you have a question?
Do gulfs count?
Do gulfs count? Yes. Most gulfs are part of larger oceans. So, like the Gulf of Mexico would be considered part of the Atlantic Ocean. So, yeah.
What do you think about things that are more enclosed, like bays, like the Hudson Bay or something like that?
That's probably still good. There could be an argument that oceans are only open oceans, and so ports might not count, because if you're improving ports, that's improving like a freshwater seawater divide, and it's not clear. Like where a river hits the ocean, is that river or ocean?
The delta.
Yeah. It's a delta, yes, but our deltas river or oceans. Yeah, the Mediterranean Sea is part of the Atlantic Ocean. Basically, intuitively, if it's a big chunk of salt water, it's an ocean. Unless it's like the Great Salt Lake in Utah. That's not an ocean. That's just a salty lake. Sorry, Utah. No one cares about Utah. That's fine. All right. Any more questions about the resolution and what the words in it mean? Yes.
Wait, so you said that like the government defines like development as like creating materials, devices, systems, and then you said that NOAA like is like restrictive of like applied research and like experiments. So like couldn't the two of those technically contradict each other?
They could. So the question was, and it's a good question, it's pointed out a sort of contradiction in those definitions that I read, is that the definition I read of exploration was like, exploration is not research. The definition I read of development was like, development's probably research too. So I think those affirmatives would just say we're development and not exploration, and because you only have to be one because of and/or, they'd be fine just saying, you know, we're doing research and we're saying that this is development. That's why development sort of lets you do whatever. It's a very, very, very inclusive word that makes this resolution quite big in terms of the ways you can interact with the ocean. Any other questions about the wording of the res? Yeah.
So it's non-military exploration, and then it doesn't specify for development, whether it's non-military.
So the way this works grammatically, it's non-military exploration and or development. So the non-military modifies both exploration and development, because we're not going to get hardcore into the grammar, but that's they both have to be non-military. So leave your aircraft carriers at home. Yes.
There's still civilian things, but they're funded by the U.S. government?
Yes. So if you argue that it's means it has to belong to the United States federal government, the exploration or development belongs to the United States federal government, then presumably this would mostly be like government programs, government protection programs, government subsidized energy creation programs, etc. And there'll be some debates about its. You will have a debate about its this year, most likely, which you probably wouldn't think that you would have coming into things. All right. Any other questions about the resolution before we move on? Cool. The resolution is the boring part because it's words and grammar. The exciting part is part 3, why you should care about oceans. Why should you care about oceans? 1. Oceans are where the life is. Oceans are where the life is. Life doesn't exist without oceans. Period. Evolution started in the oceans 3 to 4 billion years ago. Oceans are what we look for when we look at other planets to see if they could have supported human life or any sort of alien life that existed. When astronomers go and they're trying to be like, we're going to find the aliens, the thing they look for is, does this planet have water on it? Could it have supported oceans? The reason someone mentioned Mars's oceans earlier is people made a really big deal out of the fact that we found old ocean basins on Mars. Because we said, wait, doesn't that mean that Mars could have supported life in the past? The basis for all of this is that life doesn't exist without oceans. They are foundational and fundamental to every part of biological life that exists in the world. Not only are they the initial source of that life, but they are also contain most of the animal life that exists on Earth. According to marine biologists, there are at least 199,146 named marine species. So fish, coral, whatever that we've given names to, about 200,000. But there are most likely at least 750,000 total, and possibly as many as 25 million. Now, that's a pretty big gap, which again demonstrates how little exploration we've actually done of the Earth's oceans. But the takeaway point from that is that there are 200,000 to 25 million distinct species that exist in the ocean, and that's a whole lot. Just the Great Barrier Reef, just that reef outside Australia, it's the largest living structure on Earth. It's the size of Great Britain. It's covered in coral and whatnot, and its reefs are made of over 400 species of coral, supporting well over 2,000 different fish, 4,000 species of mollusk, and countless other invertebrates. The ocean contains 99% of the living space on the planet. 99% of the living space on the planet. Of places where animals can live, oceans are 99% of that. Now you might say, that seems like a lot. Well, the reason for that is that you can only live on the surface of land, unless you're a strange mole person, which you have your own problems then, but you can live under the oceans. That supports nearly 50% of all life on Earth, 50% or more, because there's so much we don't know about what's happening in the deep ocean. There could be even more life than we realize there. But 99% of the spaces where creatures can survive on Earth are in the ocean. We've done a really good job exploring that 1% on land. We've done a very poor job exploring and understanding that 99% under the ground. Second reason why you should care about oceans. Oceans are where the water is. It sounds really stupid when you say it like that. Oceans are where the water is. Water is essential to life, as discussed above. Specifically for the purposes of human life as we live it now, we need fresh water. We need fresh water to drink. We need fresh water to irrigate crops in order to eat and have food. We need water. The ocean contains a lot of the Earth's water. So the Earth's water is contained in oceans, glaciers, streams, lakes, and rivers, and ice caps. Now, what percentage of that do we think is in the ocean? Who thinks about 50% of all the Earth's water is in the ocean? 50? 60? Show of hands. 60? 70? 70% of the Earth's water? 80? 80%? Count your votes for 80. 90%? 95%? It's 97. You spoiled it. The oceans contain 97% of the Earth's water. At any given time, 97% of the Earth's water is in the oceans. Now, salt water isn't very useful for us for drinking or irrigating crops, generally, at least initially. You might think. There are ways to get salt water into non-salt water and whatnot, but if you drink salt water or try to fertilize your crops with it, you and or your crops will die. So that's not the best idea, but because it contains 97% of the Earth's water, it's key not only to the way we do agriculture and get fresh water to happen and to exist, but it's also key to what's known as the hydrological cycle, which we'll talk about more a little later on. The hydrological cycle, which is basically the cycle that water goes through. Generally what happens with water is it evaporates from the ocean, some of it comes over land, it rains down, it gets into rivers and stuff, it goes back in the ocean. That's the very short version of what the hydrological cycle looks like, but the ocean and what's in it and how polluted it is and what temperature it is makes extreme differences in the amount of rainfall we receive, in the amount of quality agriculture that we have, and in the climate that we have. So for example, you've heard of things like El Nino and La Nina, the weather patterns where the ocean is especially warm due to current patterns for a little while, and that leads to a bunch more hurricanes and whatnot. The ocean is essential to all those sorts of hydrological cycles that determine when the rain comes, etc. Third reason why you should care about the oceans. Oceans are where the people are. They're where the water are. They're where the people are. 45% of the world's population lives within 100 miles of an ocean. 45% of the world's population lives within 100 miles of an ocean. 3/4 of the world's big cities are by the sea. People naturally settled by the ocean because the ocean provides them a food source, the ocean provides transportation sources. People tended to settle near oceans. If you look at a population map of the United States, for example, it's like East Coast, West Coast, and then like Texas, and then third coast for life. But everyone tries to or tends to live near water. Cities end up being near water, which means that most of the world's cities are at relatively low sea levels, which is relevant given what scientists have said about sea levels rising. That'll be an issue that is pretty important to discuss on this topic, because as sea levels rise, if 45% of the world's populations and 75% of our largest cities are right next to oceans, then that's a problem for those cities and for those people and for everyone. And so that's somewhat of an issue. Something interesting that I came across in this when looking at United States cities that are near the ocean. So all our cities are relatively low sea level. The highest sea level of a major city is Denver, Colorado, Mile High City, obviously. It's in the Rockies. The second highest is, does anyone have a guess? Anybody? Salt Lake? Anybody else? In the Sierras? It is Atlanta, Georgia. Atlanta, you did say that, which is why I prompted you to say it again, and then you didn't raise your hand again. Courage of your convictions. But yeah, Atlanta, Georgia, we're 1,000 feet above sea level. We are the second highest up city in the United States, and you wouldn't really think of Atlanta as being like a mountain town, because it's not. That just tells you how low and near the coast most of the rest of the United States' cities are, except for Dallas, which is terrible. Fourth, the ocean is where the food is. The ocean is where the food is. About 1 billion people, plus, these are estimates, they're not great, rely on fish as their primary food source.
What percent?
About 1 billion people. So, math percent. How many people are there? I don't know.
Like 0.1.
Yeah, so 18.5% or something like that. 14. Math, again. A bunch of people rely on fish as their primary food source. Which sort of goes along with what we said earlier about a bunch of people settling in coastal areas. There are a bunch of places where it's very difficult to have food that is other than fish. Like Japan doesn't really have a lot of land to like raise cattle or chickens or anything like that, and so their primary food source is fish. And if you've eaten sushi, you understand that, and it's delicious. But a lot of people rely entirely on fish or fishing to eat. One of the issues with this is that we are fishing a lot, and there are concerns that there might not be enough fish, or we might be killing the fish, which is a little bit of a problem if 1 billion people need the fish to eat. 1 billion people rely on fish to eat, but then a whole bunch of other people eat a lot of fish without totally relying on it. Fish is one of the 3 main animal protein sources, so like meats that people eat. Fish is one of the 3 main ones. The other 2 being chicken, and does anyone want to guess? Cows, pigs, no. Goats. Bingo, goats. Goat meat. Gotta love goat meat. So fish is incredibly important to people's diets. People estimate it's somewhere between like 14 and 25% of all of the animal protein so that is eaten in the world. And so the ocean provides a lot of food. 5th reason you should care about the oceans. The oceans are what makes the climate tick. The oceans are what makes the climate tick. The reason why the NOAA is the National Ocean and Atmospheric Association is that the interplay between what's going on in the ocean and what's going on with the weather is very close. Those things are strongly related to each other. Hurricanes, entirely about currents and warmth in the oceans. Things like El Nino that I already talked about, all about the oceans. The movie The Day After Tomorrow, which was pretty bad. Anybody see that one? Yeah, it was awful. But it's about ocean currents. It's like, why does the global warming happen or the global ice age happen? It's because an ocean current shut down, and that ocean current is important to bring warm water from one place to another. And the thing we don't realize, or the climate scientists are still struggling to understand a little bit, is that because the ocean moves temperature around so much, and because relative temperatures affect winds and things like that so much, the temperature of the ocean and what's in the ocean and the chemical makeup of the ocean makes such a huge difference to the climate. Another reason why the ocean is important for climate is CO2. The ocean sucks up a lot of carbon dioxide out of the air. And so that has a big effect on things like global warming, or it could. We'll talk about that later. Sixth reason you should care about the oceans. It's where the volcanoes are. 90% of all volcanic activity occurs under the ocean. Only 10% occurs on land. There's basically the volcanic action that occurs on land is normally because there's been so many underwater volcanoes that eventually those things became islands. All the Pacific Rim islands, Japan, the Aleutian Islands, Hawaii, everything around that area, those are all volcanic islands initially created by volcanoes. Now, if 90% of volcanic activity occurs in the ocean, that also means that there's a substantial amount of tectonic activity occurring in the oceans. Big giant plates bumping into each other. That's why we have things like undersea earthquakes, and undersea earthquakes create things like tsunamis. Tsunamis have killed a whole lot of people in recent times. And they are difficult to track, and they're difficult to notice, and they're difficult to recognize because we have, again, less knowledge about the things that are happening under the ocean. So if there were to be a potential volcanic eruption in California or anywhere in the United States, we have really good sensors set up all over the place, and we could say there's probably going to be an earthquake here, it's probably going to be this level of earthquake, and we really understand, we can kind of predict, at least to some level, like when earthquakes might happen or what the earthquake risk might be. We can't really do that very well under the ocean, and that's where 90% of these things are jumping off and starting. And so both in terms of volcanic activity happening, and volcanoes can be an energy source, again, something we'll discuss later. So that's a potentially interesting thing. But also, it's where tsunamis come from, and tsunamis are just a major weather disaster that occurs that we're not really affected by in general because, you know, we're in the U.S. and the tectonic plates aren't sending tsunamis at us. But if you're a Pacific Islander, that's something that's probably on your mind. Seventh thing, why you should care about the oceans. The oceans are where trade and the economy happen. The oceans are where trade and the economy happen. 90% of intercontinental trade happens on boats. 90% of intercontinental trade happens on boats. We fly some planes to some places, but most of the time we use boats to take goods from one place to another. And that sort of transportation is essential to the way the world economy functions now. You might have oil that started in the Middle East, and that oil then took a boat down to China, where it was used to power a plant that makes some sort of made-in-China products. Those made-in-China products are put on a boat and brought to the United States, so you can buy your iPad made in China. That all happens on boats. If we didn't have those sea lines and we didn't have the ability to travel freely and easily on the oceans, the global economy would basically shut down. There is no way that the economy can function as it's currently constituted without a whole lot of sea transportation. And it's not just like trade, like transportation of goods that happens across the ocean. 50% of the Earth's communications happen via undersea ocean cables. Back in the day, if you wanted to talk to Europe, you couldn't get on a satellite phone. You banged on your telegraph machine, and that would send signals to England because a cable was run under the ocean. Most of the information transactions, if you're accessing a website from China, you are very most likely accessing that website via undersea ocean cables that provide you that data. And those undersea cables are, again, incredibly important for both the flow of information and the flow of commerce. There will be affirmatives discussed that might boost oceans communications infrastructure. Eighth reason you should care about the oceans. Eighth and final. The potential of the ocean as an energy source is huge. Potential for the ocean as an energy source is huge. And we'll talk about all the different types of energy you can get from the ocean, but it's big, it moves, wind blows there, there's oil and gas under it. There's a lot of potential that is as yet undeveloped to generate energy and electricity from the ocean. And we use a lot of energy and a lot of electricity, and so there's a constant need and a constant demand for more. And there's a constant need and a constant demand for that energy to potentially be cleaner than it is in the status quo or right now. Oceans provide an opportunity to potentially make that happen. All right, let's take a 5-minute break. True 5? True 5? Yeah, at 10:25 we'll restart things off again.